All right. So how do you represent organic compounds, the hydrocarbons? Okay. One of the thing to remember is that every carbon has four covalent bonds, all right? Because each carbon has got four valence electrons. Therefore, in the case of methane, the carbon combines with four hydrogens. Each hydrogen contributes one electron and it forms four covalent bonds. All right. These bonds are non-polar, and according to the Vesper theory, four covalent bonds means that they have to be arranged in a tetrahedral shape so as to minimize the electron pair repulsions. And so that shape has a bond angle of 109 degrees. All right. Now you can either represent this using a space filling model, which is very close to what the molecule might actually look like, or you can represent it with a ball and stick model, like so. The sticks represent the bonds. And then you can also represent what is called as the expanded structural formula, which is you're actually showing the groupings of all the atoms, how they're connected to each other. And so you see that the carbon is in the center and the four hydrogen atoms surround it with four single covalent bonds. Or you can condense it to just show how the carbon and hydrogens are grouped together. Sometimes it's also, when you write it this way, referred to as molecular formula, because it's just showing you the numbers of each type of atom present in the compound. Or if you want to represent a 3D version on paper, kind of like the ball and stick model, then what you can do is you can try that. And so those two bonds which are in the plane of the paper are represented with lines, and the bond that is coming out of the plane of the paper is represented with this wedge, and then the bond that is behind the carbon, okay, going into the paper, so to speak, is presented with a dashed line. So that's called as the wedge dash model. Okay. All right, so you have CH4, which is kind of the condensed version of the formula, or the expanded structural formula showing how all the atoms are attached in a two-dimensional way, or the 3D structures are either using models or drawing it this way, okay, so as to be very close to what the actual molecule looks like. Now all the bonds are single covalent bonds, and therefore this hydrocarbon is called as saturated. If there was any kind of double or triple bonds, it would be called unsaturated. All right. So since they're all single bonds, it's a saturated hydrocarbon. Okay. Now meth means one carbon. All right. So the prefix meth as one carbon, the prefix eth means two carbons. Ane signifies that they are all single bonds. All right. So that ane group, alkane, that's their functional group. The functional group signifies that all the bonds, especially the carbon to carbon bonds, are single bonds. Okay. So two of those carbons in ethane are connected by a single bond, and therefore, since carbon forms only four bonds, the other three bonds are completed by hydrogen. So each carbon has got three hydrogens. All right. So again, you have the wedge dash model and the expanded structural formula, and then the condensed version, which shows the groupings of the atoms. All right, that each carbon has three hydrogens bonded to it. All right, and this can be a little not accurate, because it looks like the hydrogen is connected to the carbon. It's actually in the expanded structural formula, it's more accurate, because you can see that the two carbons are connected together and those three hydrogens are connected to the carbons. All right. All right, so what would be the shape around each carbon in a compound like butane? All right, so the But, the prefix, signifies that there are 4 carbons, and ane means that they're all single bonds. All right, so butane is 4 carbons. The 2 carbons on the end have 3 hydrogens because carbon has to have 4 bonds. The 2 carbons in the middle have 2 hydrogens. All right, okay. Around each carbon there will be a tetrahedron. All right, so in actuality it won't be flat like this, it'll go up. So it'll go up like this, come down, then go up again. All right, it kind of like a zigzag type of shape. Okay, so each carbon has 4 covalent bonds and a tetrahedral shape around each carbon. Okay, so the hydrocarbon, the functional groups of hydrocarbons. So remember, hydrocarbon means there are only 2 elements present, hydrogen and carbon. All right, so they can be characterized into carbon-carbon single bonds, alkanes, carbon double bonds, alkenes. In means double, ene means single, and alkynes, which means a carbon-carbon triple bond is present in the compound. Right, and then the last set of hydrocarbons are called as aromatic. As the name signifies, they have a strong smell. They're associated with a strong smell, sometimes not very pleasant, kind of pungent. And then they have this ring structure where the carbons are connected in this hexagon type of ring. Okay, now each point here in the hexagon signifies a carbon. All right, and each carbon is attached to to 1 hydrogen. Okay, and there are 3 single bonds between those 6 carbons and 3 double bonds. All right, now since those single and double bonds are not fixed in space but they're constantly moving, so therefore then those bonds are not even represented with lines but rather with a circle. Okay, is showing what is called as resonance. All right, the movement of those bonds, meaning that you're able to get a couple of structures where it might be single over here, and then another equivalent structure would show it to be double, and so on. So the single and double bonds are kind of moving. The bond lengths are neither single nor double, or they're kind of in between. So this circle represent resonance. Okay, so this kind of uh, 6 carbon ring structure with this resonance signifying that there are at least 2 structures that are possible in this kind of ring compound is called as a benzene ring. All right, so the aromatic compounds all have this as their functional group, is the benzene ring. All right, moving on to section 12.2, we're going to look at how to name these and draw these alkanes. All right, so we looked at at least 3 of them. Methane, which was just 1 carbon, that we looked at the 2 carbons, which was ethane, and now this is propane. Okay, so you have, as you can see, each carbon has that zigzag or the tetrahedral shape around it, leading to the zigzag kind of shape, or in other words, another word for shape is conformation. All right, so it has this kind of it's going up and down, so to speak, like an inverted V. All right, so that would be propane. Okay, and so the end carbons have 3 hydrogens, and the middle always has 2 hydrogens. So that way that the carbons are connected is called as a continuous chain. And this system of naming is based on a system called as abbreviated or given the acronym IUPAC or IUPAC, International Union of Pure and Applied Chemistry. Okay, so ene indicates that the bonds are single. Okay, the prefixes indicate the numbers of carbon present within the chain. All right, So you have meth, which is 1 carbon, eth 2 carbons, prop 3, bute 4, and once you go past the 4 carbons, when it becomes 5 or more, it's all Greek prefixes like pent and hex and so on. Okay, so as you can see here, as the number of carbons increases 5 to 10, all right, this is pentane, all right. So this, when you write it like this without showing how the atoms are connected, it's called the molecular formula. So pentane is 5 carbons, hexane is 6, heptane is 7, octane, which is gasoline mostly, is 8, nonane is 9 carbons, and decane is 10 carbons. Okay, and as the continuous carbon chain is expanding, you can see that the number of CH2s in the middle increases. Okay, so you can it, it- each of the higher hydrocarbons, the way they're increasing is by 1 CH2. All right, so this is 1 CH2 more. Propane is 1 CH2 more than ethane, and then butane is 1 CH2 more than propane, and so on. So the number of CH2 keep on increasing. Okay, now another way to represent these so as to be more accurate is using lines. All right, so methane, of course, is just 1 carbon, so you can't use a line, but for ethane you can use just a single line. So the ends are indicating that there's 2 carbons at each end, and it's understood if it's an end carbon, there's 3 hydrogens. All right, so you do not actually write out the symbols of the atoms, uh, but you simply represent everything with lines. All right, so propane is shown by this inverted V, and then butane is shown by it like the zigzag. This is called as the zigzag structure. It goes up, comes down, goes up, and so on. All right, so you're simply counting the number of points in the zigzag line to see how many carbons are present. So as you can see here with decane, you have 1 2 3 4 5 6 7 8 9 and 10 points. Okay, so at the ends of the line, it's CH3. In the middle, the midpoints have a CH2. Okay, so when you condense it, you group those carbons and hydrogens that are joined up together. All right, so the end carbons are CH3 and the middle carbons are CH2. All right, the subscript indicates the numbers of hydrogen that is bonded to that particular carbon. And then you have the line angle structural formula, which is representing these structures with just lines. All right, so zigzag lines, the ends have 3 hydrogens, the middle points have 2 hydrogens. All right, each point has a carbon there. All right, so how do you draw these structural formulas when you're given the name? First, start with drawing the carbon chain. All right, so if you're given the name hexane, draw out 6 carbons all connected together as a continuous chain. Okay, and then you can go about adding the hydrogens, 3 at the ends, 2 to the middle carbons. All right, and then once you have the condensed structural formula or the expanded structural formula, then you can go about drawing those line structures. Okay, so it says pentane. All right, so first draw the carbon skeleton, which is just connecting 5 carbons by single bonds. Okay, then fill in the hydrogens in the expanded structural formula, and then go about indicating each carbon, all right, with a zigzag line, one up, one down, one up, and so on. Okay, so it's going to go up and then come down here, and then go up for this, and then come down. All right. Okay. All right. So then you can take this expanded, make it into condense, and sometimes you don't even have to write this, draw this line between the carbons. I don't. That's a personal preference. Okay, and then from the condensed you will just draw the line structural formula to indicate those 5 carbons. Right, and we'll stop here.